Okay. Okay, hello everybody. Hope you're all doing well today. I am just testing out the audio very quickly so that we can make sure everyone can hear us properly. All right, so it sounds like everything is on track here. I am just going to open up our file and we're going to get started. So, welcome to the grade 9 hour of freemathhelp.ca, brought to you by Scholarly Elite Tutoring. I hope you're all having a really great day so far. Um, Today, we're going to focus on something that is one of the most requested topics for tutoring, and that is solving linear equations with fractional coefficients. And if you haven't heard those words before, that's okay. We're going to talk about all of that today and what it means, because this is actually a skill that really matters for the rest of all of high school math. And so I hope that today can give you some ideas on how you can continue to solve these types of questions, because I personally remember being in high school and being very confused by this because it was never explained thoroughly. And it's a very, very important skill. So I think that it's really good that we go through each piece of it and understand why we solve these things the way that we do. So, like I said, we're going to be solving linear equations. And what we're really doing is solving things algebraically. And what that means is that we're going to be looking for what the unknown coefficient is. So, let's get started without further ado. Or without further ado, let's get started is what I meant to say. Now, what's really important for you to understand is that when we talk about solving fractional coefficients, what we're really starting with at its core is understanding how the multiplication and division of fractions work. So before we get into bringing any algebra into this, I want us first to understand how we multiply or divide fractions. So first and foremost, when we're talking about fractions, say we're being asked to multiply two fractions. So say I had 5 over 2 times, let's say 3 over, I don't know, 4, for example. Okay? So when we're multiplying fractions, we have to multiply their denominators by each other. By the numerators with each other and the denominators. So let's do the numerators first. We've got 5 times 3, which is 15, and then 2 times 4, which is 8. Now we ask ourselves, can this be reduced? Is there any number that goes both into 15 and into 8? And there is not. So that's our final answer. When we're dividing fractions, we get, let's say, for example, we're dividing 10 over 3 divided by, let's say, 5 over 2. And in this situation, what we need to do is we take this second fraction and we flip it. So we go 10 over 3 times 2 over 5. And we multiply the numerators by the numerators and the denominators by the denominators. So we get 20 over 15. And then we can reduce this by asking ourselves, is there a number that goes both into the numerator and into the denominator? And in this case, we can reduce this by 5. So I'm going to divide the top by 5, and I'm going to divide the bottom by 5, because that's how this works. You have to do in a reduction where you're dividing both the numerator and the denominator by the same thing. That's the only way to reduce. So 20 divided by 5 is 4, and 15 divided by 5 is 3, and then this is our final answer. Okay, so I preface this lesson with this concept because really when we're talking about fractional coefficients in algebra, it's very important to understand how we do this. So what we're going to eventually be talking about are equations like, for example, let's say, 8 over 3 equals x minus 1 and 1/3. Now, we're not going to do this question right now, but the whole point of what I'm talking about is that I need us to understand how we're going to get this as simplified as possible. So before we get into questions like this, we have to understand how a particular part of multiplying and dividing fractions works. So let's say, for example, I had 2 times 5 over 2. And I know I keep using 5 over 2, but I just think it's a very clean fraction. So in this scenario, what's really happening is that I'm being asked to multiply 2 by this fraction. But what we know about all numbers is that technically every number is over the number 1. And that's true of any number. You have -5, technically it's the same thing as saying -5 over 1. If you had 17, it's the same thing as saying 17 over 1. The reason for this is because technically with this fraction, you're saying 17 divided by 1, and 17 divided by 1 is 17. So that stays the same, and that's why they're equal. It means the same thing. So keeping all of this in mind, one thing we need to remember is that, again, when we're being asked to do a question like 2 times 5 over 2, another way of thinking about it is this, where we have 2 over 1 times 5 over 2. So in that scenario, and I'll write it here a little bit cleaner for you, what happens in this scenario? Well, we do multiplying the numerators by the numerators, so 5 times 2 is 10, and we multiply the denominators by the denominators, which is 2. So 2 times 1 is 2. And then in the end, we get 5. So here's the cool thing I want to show you guys. So this is one way of doing it, right? Another way of doing this is actually very, very simple once we get the hang of it. And it's going to make your life in math so much easier because once we understand this concept very well, it really, really resonates and helps us understand more complex problems. So what we're going to do is we're going to go ahead and try this same problem, the one in the cloud here. So again, I'm going to go 2 times 5 over 2, which is the same thing as saying 2 over 1. Because again, anytime you have a number by itself, you can also say that it's over the number 1, times 5 over 2. And instead of doing this part where we actually do the multiplication across, and then we do this back end stuff, what we're going to do instead is actually cancel out these 2's. And I'm going to show you why. So the way that we can rewrite this is 2 times 5 in the numerator and 2 in the denominator. And now because we have this same number in the numerator and in the denominator, and there's nothing else attached to it, we can just cancel these out. And we get the number 5. So as you can see, we got the same answer, but it was much faster to achieve this. And it gets to be much faster, especially when you can skip a couple steps. So I'm going to do one more example in this same manner, and then we're going to apply this to algebra. And if anyone has any questions, you're fun. Can you solve this, please? Yeah, if you have any questions you'd like me to solve, please feel free to leave them in the comments, okay? I just can't see any comments with the question in it. If you can't send your question in the comments, please feel free to also email it to us. We have an email address, admin@Scholarly Elite. And we usually have all that information down in this black box here, but actually this week, in solidarity with the Black Lives Matter movement, we are going to keep that black box there. So I'm just going to put our email address here for you guys if anyone needs to email us a more complex question. Oops, there we go. So yeah, Irfan, if you want to send a question into the chat, feel free. I can answer it for you, okay? So while we're waiting for that, I'm just going to try out another one of these. So again, so let's say we have 7 times 2x over 7. When I go ahead and change this into 7 over 1 times 2x over 7, I can rewrite this like this. 7 times 2x over 7. And these 7's cancel out, and I'm just left with 2x. Okay, so now I'm going to show you what happens when you have a larger number up here. So let's say, for example, I had 12, and then here I had 3y over 4. Well, when I am going to bring this together, I'm going to get 12 times 3y over 4. And instead of worrying about the whole thing in the multiplication here, what I'm going to ask myself is how many times does 4 go into 12? And that means I'm going to divide 4 into both of these and see what I get. So what I'm going to get is 12 divided by 4 is 3. The 3y stays the same because I'm not reducing that right now. And then 4 divided by 4 is 1. So my answer here is 3 times 3y, which ends up being 9y. And that's our final answer. Okay, great. So all of this is just the kind of the preface to what we're really talking about today. I'll leave that up for about 5 seconds there so anyone who's following along can take a look. And then we will move on over to doing more complex stuff. And again, so yes, if anybody has questions, they don't have to relate to today's question, to today's lesson, I mean. They can be about any grade 9 math topic that you have to work on right now for school. That's why we're here. We really want to give you guys that opportunity to ask questions live, because I know that a lot of teachers are not being allowed to do live streams or any live instruction right now. So that's really why we've put this together, to help you guys out as much as we can, okay? Alrighty. So let's take a look at a more complex problem. So all that stuff we just learned is really important when we're solving equations with fractional coefficients. And so when we have a problem such as this, if I was to ask you m plus 4 equals 13 over 2. And in a situation like this, if I was to try to isolate for m, really what I would have to do is get rid of that 2 that's in the denominator. And the reason for that is because eventually, when I'm trying to add together everything else, it's going to be very important for me to be able to have no fractions in my coefficients or in my problem. So I'm going to show you guys how we can do that, and it's based on everything we just learned, okay? So remember that with algebra, if you do something to one side, you have to do it to both sides. And you have to do it to everything in the problem individually. So in this case, if my denominator that I want to get rid of is 2, then that means that the only way I can really get rid of it, or one of the main ways I can get rid of it, is by multiplying every single term in this equation by 2. And I'm going to show you how that looks, okay? So remember that my goal is to get rid of this 2 in this denominator, because again, when you're solving algebraic problems, questions, equations, whatever you want to call them, realistically, having coefficients that are fractions or even having just numbers that are fractions can be problematic for us. So let's go ahead and multiply everything by 2. So I'm going to multiply, and actually I'm going to use a different color. Oops. I'm going to use a different color here just to illustrate what I'm doing. So first I'm going to rewrite these things that I have in black again. So m plus 4 equals 13 over 2. And now I'm going to do this multiplication. So let's do this with blue. and I'm multiplying 2 in front of everything. Because again, this is algebra, and in algebra, that's what you have to do. So just like we were learning before with canceling stuff out in fractions right here, right? This is why I was showing you guys this stuff, because now it's going to come in handy understanding that as we move forward in this. Okay. And Irfan, just to let you know, for some reason I can't see any, I don't see any questions. I don't know if you're trying to like upload something. I'm going to check our email here at Scholarly Elite just to see if you emailed us. Again, if you have a question that would be easier to email us, you can send us that question here, admin@scholarlyelite.com. So let's just take a look here, make sure that I don't have any question emails. And let's see here. No, I don't see anything from anyone. So, well, we do have emails, but just not about this. So if you guys, again, if you want to send us an email, admin@scholarlyelite.com. Okay. So let's go ahead and do these multiplications. So 2 times m is going to be 2m. 2 times 4 is going to be 8. And then where it gets interesting is this right here. So again, remember that what we were doing before in these questions was that when we had the same numerator, something in the numerator and in the denominator that could be canceled out, that's what we were doing. Because if you think about it, like for example, in this question, the reason that they cancel is because 7 divided by 7 is 1. And that's really what's happening. So I think a lot of times we teach kids that, this concept of canceling, when in fact, it's not really canceling in that sense. It's just being divided by itself. So 2 divided by 2, which is what's happening here, because if I was to rewrite this piece here, it would look like 2 times 13 divided by 2, and I can cancel these 2's here. So that was the whole purpose of what we just did. And now we're going to be left with 2m plus 8 equals 13. And then from there, we can just go ahead and solve algebraically, which is much easier now that we have no fractions. So I'm going to have this turn into 2m equals 13 minus 8. Oops, that's an 8. And what we're left with is 2m equals 5. And then we just divide the 2 off of m, cancel those out, and our final answer is m equals 5 over 2. Okay, so this is something that we really focus on in our Elite Math Mastery program, because a lot of times the problem with the Ontario curriculum, you guys, is that it doesn't actually teach you guys these core math skills. And then it expects you to apply core math skills to more complex problems, which in turn makes things that aren't that complicated seem much more complicated than they really are. So I highly recommend, if you guys are going to be practicing math over the summer, or if you're one of our Elite Math Mastery students, which we will structure that for you if you are, but for those of you who might not have any plans for the summer yet in terms of math learning, I highly recommend practicing these types of questions, because they are really kind of at the core of what we're going to be doing for the rest of high school math. This is a concept that's so important. And for those of us who struggle in this area, in the beginning, it can be very difficult to pick up the pieces as things get more complex. So I think I've done enough rambling there. I will move on to the next page here. If anyone has any questions about this, just let me know. Okay. Oh, I just got Irfan's question by email, so give me 1 second. Solve each system by substitution, y equals 6 minus 11. Okay. So Irfan, either you are in grade 10 or this is a really, really intense grade 9 question, but we will do it. 12 y equals 6 x minus 11 minus 2x minus 3y. So for those of you who are in grade 9 and are watching this, I really actually think this is a great question for grade 9s to understand as well. So I'm happy to teach this in the grade 9 class as well, because even though this is kind of something that typically gets taught in grade 10, it is really, really based in grade 9 principles. So let me just expand this so everyone can see the question. So the question is, solve each system by substitution. Y equals 6x minus 11, and then negative 2x minus 3y equals negative 7. So thank you, Irfan, for bringing this to our attention. We are going to take a look at this and solve this piece by piece. So for the first thing I want to say when we're talking about, oh, you are grade 9. So Irfan, you have a very, very intense grade 9 teacher, and props to your teacher for teaching you guys this year, because a lot of teachers don't. So way to go. And this is a very, very hard question for grade 9 level. So I can definitely understand why this is a lot for what you guys have been taught in the grade 9 curriculum. So, okay, when they talk about solving systems, what they're really saying is find out the point of intersection. And what I mean by that is if we were to have as we can see here, oh my gosh. Whoa, what did I do? Give me a second, guys. I don't know what's going on here. There we go. Basically, I can't seem to get my thing on this. I don't know why it's not letting me do that. Okay, that's fine. Basically, these are linear systems. These are linear equations, as we have learned. So if we're thinking about these like y equals mx plus b, for this first problem here, we can take a look at this. This is the slope. This is the y-intercept. And even though that's not really what they're asking in this question in terms of, thinking about these as linear systems, when we're solving these types of questions and when they say solve each system, what they're really asking is for you to find out where these two systems intersect. Okay? So what we're going to do is actually very simple, but it involves a little bit of finessing. So I'm going to show you what I mean. What they mean by substitution is put everything in terms of one unknown variable. And so in this case, my first linear system, and we'll call this linear system number 1, is y equals 6x minus 11. So we are saying that this system is A, linear, and B, all of this is equal to y. And if what we're asking is for the point of intersection of these two systems, then the x value and the y value are going to be identical for them. So, for example, and this is not this system. Like this is, I'm going to draw this just to show you guys, but this is not what I'm showing here. Okay, so say I had 2 lines and it was like this line and this line. When they're saying solve, what they're asking for in actuality is this point where the 2 lines hit each other. And so at this point, both the x value and the y value for both systems are going to be the same. So I hope that makes sense so far. Now, when they're asking us to solve algebraically, what they're asking us to do is to take something from the first system and plug it into the second system or vice versa. So in this case, I have solved that my entire y value is equal to 6x minus 11. So what I'm going to do now is, instead of saying y here, I'm going to plug in this y. And how that's going to look is as follows. So let's say, and let me move this over so everyone can see a little bit better. So because here I have my equation, it's negative 2x minus 3y equals negative 7. But instead of saying y, I'm going to say 6x minus 11. Because I know that 6x minus 11 equals y. Okay? So this is how this is going to look. 2x minus 3. And instead of y, I'm going to plug in 6x minus 11. That's an x. There we go. Equals negative 7. So do you notice how everything else in the equation stayed the same? Even the negative 3 in the front? Only thing that changed here was y. And that's what they mean by substitute. They're saying instead of saying y, use another term for it. So it's kind of like how you pick something out of the thesaurus to mean the same thing. So it's like a synonym. So instead of saying y, the synonym of y is 6x minus 11. And all that really is like saying, and I use this example all the time, instead of saying humans, we would say Homo sapiens. And it means the same thing. Okay? So anyways, let's go ahead and solve this. So now we've literally plugged in 6x minus 11 instead of y. And what we're going to do now is actually expand this problem. So we've got negative 2x staying the same because there's nothing affecting it right now. And I need to multiply this negative 3 into these two terms. So negative 3 times 6 going to be negative 18x. That's a negative. Let me fix that. Negative 18x. Negative 3 times negative 11. Well, we've got a negative times a negative, so that's going to be positive 33. And that's one thing I want you guys to be very careful of in these kind of problems. Always make sure that if this is a negative 3 or a negative whatever number, you're multiplying it in as a negative. And then here we've got negative 7. Very good. Okay, so now what we need to do is collect our like terms. So I've got two like terms over here, the ones with the x's on them. So I've got negative 2x minus 18x. And then I've got these like terms of positive 33 and negative 7. So first let's collect this like term. Negative 2x minus 18x is negative 20x. And then I've still got positive 33 equals negative 7. And just like with all algebraic problems, we need to isolate for x. So let's go ahead and do that. We're going to move the 33 over to the other side. So that means we're left with negative 20x equals negative 7 minus 33, because as it changes to the other side, it changes signs as well. And that leaves us with negative 20x equals negative 40. And then again, we're just going to solve algebraically. So I'm going to divide off negative 20 off of both sides. On this side, negative 20 divided by negative 20 is 1. So that cancels. I'm left with x by itself. And on this side, negative 40 divided by negative 20 is 2. So this is the first part of this answer. X equals 2. So now I'm going to take this, and I'm going to move all the way back up to my original question. So I now know that the x value of the intersection point is 2, and I can plug that into either one of my equations, and I'm going to pick this one because it's easier. So now instead of writing x, I'm going to write 2. So if my original equation 1 was y equals 6x minus 11, then I'm going to plug in the number 2 instead of x. So it's going to be y equals 6 times 2 minus 11, which gives us 12 minus 11 for y, and that gives us 1. So the final answer for this question, because again, when they're asking us to solve a system, that means they're asking for a point of intersection and they want you to literally give them an actual point on the graph. So the final answer for this question is going to be in the bracket xy form, and it's going to be 2, 1. And this is x, and this is y. So again, all they're asking for with questions like this are to solve the point of intersection. And when they say substitution, they're just asking you to use what I like to call math synonyms to plug stuff in. So if you have a question like this, and we're going to do another example because I really am so glad that Irfan brought this to the class today because it's a very, very important concept and it's going to be a whole unit for you guys in grade 10, which is why I was asking if she's in grade 10 or not, if they're in grade 10, sorry, because this is a whole unit in grade 10 and they teach you a couple other ways to do this. I personally like substitution best. That said, it is a little bit complicated, and so it's important to understand the steps. So before we move on to the next question, what we're going to do is kind of reiterate what we did for this question, okay? So over here, looking up here, I labeled each linear equation as 1 and 2, and in this situation, I already had one of my variables by itself and equal to the rest of the problem. If I did not have that, I would have to isolate. And we're going to do a problem in a second where we are going to isolate. But what this really comes down to is the fact that because I have y by itself and I know that y equals 6x minus 11, I'm going to use my math synonym, which is another way of calling substitution, right here, and plug in that value, 6x minus 11, into this concept. So we can only do this when we know that these two equations are equal to each other. And the reason that they're equal to each other, again, is because they are intersecting. And we're asking for the point of intersection. Okay? So I hope that makes sense. If Irfan or anybody else has questions, you're more than welcome to drop them in the chat. You can, again, also email them to us. No problem. Because these are very complex questions. So really glad you guys brought this to us today. Let's do another solving by substitution. I'm going to make up, oh, here's my thingy. There we go. I'm going to make up the numbers for this one. Should I? Let's see here. Give me 1 second. Maybe I can find in my grade 10 book something like this so that we can just do that. So okay, here's a good example for this. So again, we're going to be asked to solve the system by substitution. So let me type that in here. So Irfan, I hope that was helpful. If you have another question that you have for class that's similar to this and you want me to answer that, feel free to send that in the chat or by email again as well. But I'm going to do another example just to give everyone a good idea of what it is that we just did. Okay, so solve the system by substitution. Sorry, the system. Good. So the system is going to look like this. Y minus 4x. Y minus 4x plus 1. Trying to space everything out. 0 equals 0. And then the second part is 4x minus 5y plus 3. Great. Yay. Okay, so I hope everyone can see that. This is my question. So we're being asked to solve the system by substitution. And again, when we hear the word substitution, we're really just saying to ourselves, that's a math synonym. So this question is a little bit different than the one we just did, because in the one we just did, we already had one of the equations equal to one variable. And that was equation number 1. If you remember from this one, you see here, it was already equal to y. And in our new question, we don't have that. So we have to create that ourselves. And just by looking at this here, I'm going to say to myself, well, I'm always going to pick the easier one to do, because that's just how we should always operate in grade 9. Actually, in math in general, I like to say, do not overcomplicate your thing, overcomplicate questions. There's a concept in science called the law of parsimony, and it basically means that the simplest answer is usually the correct answer. And that's my philosophy for teaching math, is actually simplifying things as much as humanly possible. So, let's take a look at this. First thing I want to do, step 1, is label these as equation 1 and equation 2. Wonderful. So now I'm going to take equation 1 and isolate one variable. Okay, so let's go ahead and do that. How do we isolate? Well, isolating a variable is just algebra, simple algebra. So if we have everything here and it's y equals, y minus 4x plus 1 equals 0, and I want to isolate for y, then I need to move everything else to the other side of the equation. So what we're going to do is just simple algebra. Let's start with this positive 1. It's going to be y minus 4x equals 0 minus 1, which is negative 1. And then I need to move over the negative 4x as well. So this is going to become y equals positive 4x, because I moved it over and it was negative on this side, and it's going to become positive on this side, minus 1, because minus 1 was already over here. And I've now isolated for y. So I'm going to take this information. Oops, there we go. So if I know that y equals, I'm trying to draw like a fancy y here, you guys. If I know that y equals, very Netflixy looking y, y equals, I'll say it again, 4x minus 1, then I can take this information and plug it in right here. Okay, so let me actually make that arrow a little bit better. I'm going to take this information and plug it in to my second equation. Because again, all we're really asking for is at what point of x and y do these two things equal each other? So now let's look at equation 2. It's 4x minus 5y plus 3 equals 0, right? So if I'm substituting for y, it's going to look like this. 4x stays the same, minus 5 stays the same. The only thing that's going to change is that I'm going to put my answer for what y equals, which is 4x minus 1, right here instead of y. Because again, it's a synonym for y. Let me get back to my black pencil here, pen or whatever it's called. There we go. But everything else in my equation stays the same. Positive 3 keeps exactly where it is. Equals 0 stays as it is. Wonderful. So now, as per the rules of BEDMAS, we have to solve this using our multiplication. So again, 4x stays the same. And now we're going to say minus 5 multiplied into both of these terms. So minus 5 times 4x is going to be negative 20x. Minus 5 times minus 1 is going to be positive 5. And then again, positive 3 stays the same because nothing was happening to it over here. It's just chilling. Equals 0. And then yay! Now all we have to do, collect like terms, and then solve for x. So again, these problems look a lot more complicated than they are, and I say this for a lot of math problems. And this is because I remember being in high school very vividly, and I remember just feeling so lost. And I wish that someone had explained things to me in a way that just broke it down as simple as possible. So that's our philosophy at Scholarly Elite, is that we simplify complex systems. We simplify things so that you can understand them in a way that makes sense. And part of that is understanding the core values of algebra and how all of these things work. So again, if you guys are not in our Elite Math Mastery program at Scholarly, I highly recommend, even if you don't come through us to do it, if you're working on your own at home, practice your algebra skills, you guys. They are so fundamental in the understanding of math. And so I highly, highly recommend you just, even if you just find algebra sheets online, you can totally do it. And it's going to help you for the rest of high school math, especially if you want to go into the sciences. You're going to need these skills. Okay. Anyways, I'm going to stop boring you now. I'm going to get back to solving this. So 4x minus 20 is going to be negative 16x. And then positive 5 plus 3 is going to be positive 8. That's going to equal 0. And then all I need to do is solve for x. So let's start out by moving 18 over. Or not 18, 8, sorry. So 0 minus 8 is negative 8. And then I need to isolate this by dividing off negative 16. And what we get here is x equals a half. Okay, so that means I've solved the first part of my question, right? So again, what did we do so far? We isolated for one variable is what I was trying to say. Isolate for one variable, that's step 1. If it's not already isolated for you. If it is, that's awesome. But in this case, it wasn't. Then we take that isolated variable and use it as a math synonym to plug into our other equation. And now, so this was step 1. This is step 2. Now let's go ahead and do step 3. So step 3 is we take this value of x, and again, we use it as a math synonym, and we pick one of our systems. It doesn't matter which one, you guys. You can use either, because again, the whole point of this is that we're asking for at what point are they equal? And so if you use 1 or 2, you're going to get the same answer. I always like to choose the easier one because you're going to get the same amount of marks for picking the easier one as you are picking the harder one. So there's no point in making things complex for yourself. So let's go ahead. Equation number 1 is y minus 4x plus 1 equals 0. Or you could use the isolated equation that we just solved. Doesn't really matter. So this rearranged is y equals 4x minus 1. And I'm going to take this value of x, and this time I'm going to use blue, right? X equals a half. And so in this question, instead of the letter x, I'm literally going to plug in a half. So y equals 4 times 1/2 minus 1. Very good. So 4 times a half is 4 times 1 divided by 2, which is 2, minus 1. So y equals 1. Okay. So our final answer for this question is that the solution to this system is bracket 1/2 1. Because again, x, y. Okay. Let us now use this information to our advantage. What I want us to do, I'm going to leave up this problem, but I want us to graph this so I can show you guys what's happening here. Because that's really going to make, in my mind, that's what helped me when I was in grade 10, when I was first learning this, to really grasp what was happening. So we know that our point of intersection occurs at 1/2, 1. So that's going to be here somewhere, right there. Now, what we're going to do is actually graph these systems. So if I have 4x minus 1, then I'm going to graph that first. Let's use a red pen here. So if I know that -1 is my point of, what's it called? My y-intercept, and that I'm moving up by 4 and over by 1. So basically, let me just show you guys. We'll put some dots down. We'll do this. So I know that this is my y-intercept. Rise over run. So 1, 2, 3, 4, 1 over. 1, 2, 3, 4, 1 over. So I've now got 3 points. And let me get one more. 1, 2, 4. Oh, 1 over. Okay, so I'm going to connect these dots to give us our line. Now bear with me because sometimes I have to. It takes a little bit of finessing to figure this out. Okay, there we go. Oh, damn it. Got it. Went away. Okay, there we go. Okay, so this is the line for equation 1, y equals 4x minus 1, because that's the format that we want to put it in. So let's go ahead and do equation 2 in blue. So first I need to actually figure out what equation 2 is. So I'm going to quickly do that over here. So if my original equation was 4x minus 5y plus 3 equals 0, I want this in y equals mx plus b form. So I'm going to move everything over to the other side. So it's 5y equals negative 4x minus 3. And then I'm going to divide by negative 5 all around. So my final answer is going to be y equals 4 over 5 and plus 3 over 5. Oh, x in there. Okay, so in this scenario, basically I would be actually graphing this. So if my y-intercept is 3 over 5, that's 0.6. So let me just graph that quickly. Again, you don't have to do this. I'm just doing this to show you guys what we're doing in this problem. So 0.6 would be somewhere like right here. Okay, great. Good. Okay. And then we've got a rise of 4 and a run of 5. So we're going to go up by 4. 1, 2, 3, 4. And then over by 5. That's about there. Then I'm going to go the other side just so that we can make sure we can get this perfectly. So we're moving over by 5. 1, 3, 4. Oops. There we go. Dang it. Here we go. There we go. Okay, so now let's actually put this line in. I don't know why it always gets rid of that dot first. Anyways, this line is like this. Okay. So what I'm really trying to show you guys is what this point of intersection is. Okay, so we've now accomplished our point of intersection. So we know our point of intersection is x half y1. And if we look at this graph right there, that is our point of intersection. 1/2, 1. So when they're saying solve by substitution, they're basically giving you an out in the sense that they're not asking you to graph, because as you can tell, it's much more annoying to graph it because some of these get really complicated and then sometimes it takes a long time. But it's very, very important that you label everything. So for example, this is y equals 4/5x plus 3/5. Okay, so as you guys can see, we've now solved for the point of intersection, which is also called solving the system, by substitution and by graphing. There are two other ways to do this. You don't learn them until grade 10, so it's totally fine. But this is a very, very important skill, like I said, because it will bring you a lot of ease in your future math work in general if you decide to do this in a way that makes sense to you. So if anyone has any questions about the stuff we've learned so far, feel free to drop them in the chat or again to email them. I thank Irfan a lot for submitting this question because this is a great question. And like I said, most grade 9 classes don't teach this. Most teachers won't teach this in grade 9, but I actually think it's better to learn it in grade 9 than in grade 10 because in grade 10, you're learning a bunch of ways to do this. Can you do a question by using this formula? Yep, I absolutely can. So we're going to do, and actually, Irfan, if you look at this question right here, the question we just did, that does follow that formula. But I'm going to do another one because it's actually a really good question. So Irfan is asking if we can do a question using the formula ax plus by plus c equals 0. And that formula is the standard format, the standard way of writing a linear equation. So let's do another one. We have 8 more minutes, so we should be good for time. So let's go ahead and bring up our black pencil here. So let's do this one. We've got 3x minus 4. Actually, you know what? Before I start writing that, let's do this. Let's actually write out the formula Irfan is saying. So ax plus by plus c equals 0. And let's line these up right underneath so that everyone can kind of see what we're talking about. So just because the original formula has positives in it, so it's like positive by, positive c, for the most part, you will never get a question that's all positives or all negatives. This is just your standard understanding formula so that we can kind of look at it, right? But most of the time, you'll get questions that have either a negative or a positive. So let's say we have 3x minus 4y. It still follows that same understanding because the big letters here, A and B and C, they just represent numbers. For A and B, they represent coefficients, which means that they're in front of an unknown variable. And for C, it just represents a regular number. So let's say I have this is minus 20 equals 0. And then my other one is x. Let's say it's 4x plus 12y plus 8 equals 0. Okay, so again, first thing we want to do is label, label, label. We love labeling stuff. So this is going to be called equation 1, and this is going to be called equation 2. Great. Then what we want to do, as we've done so many times, not so many times, in this past few times. So remember, step 1, label and isolate. So when we say isolate, that just means we pick one of these problems and we isolate everything in terms of one unknown variable. And all that means is you basically say, do you want to solve for problem 1 or do you want to solve for the second one? I personally think that problem 2 looks easier to solve. So we're going to go ahead and solve and isolate for one variable. In this case, I'm going to isolate for x because we keep isolating for y. So let's go ahead and do that. I'm going to isolate everything here. So we want 4x by itself. I'm going to move everything to the other side. So 4x, and then moving positive 12y and plus 8 to the other side. So that's going to look like 4x equals, shifting that over. So negative 12y, negative 8. Okay. So now what we're going to do is isolate for x, because again, when we say isolate, we really mean that we only want x by itself, aka 1x. And the only way to do that is to divide everything off of it. So in this case, positive 4 is multiplied by x. The opposite of that, the opposite operation, is dividing by 4. Here we go. Divide both of these by 4. Okay. Now what we need to do, cancel that out because 4 divided by 4 is 1. Negative 12 divided by 4 is negative 3. The y is still attached. Negative 8 divided by 4 is negative 2. And so now we have our beautiful x isolated by itself. And that's what we wanted. So here was our step 1. Yay! Let's go ahead and do step 2. So if you recall from earlier, step 2, actually, you know what? Let's do step 2 underneath. So step 2, first actually before I show you that, step 2, all you have to do is take this newfound information of x isolated. So in this case, we've got x equals negative 3y minus 2. And I'm just going to plug that in. I'm going to pick one of my equations. I'm going to pick the other equation is what I meant to say. So I'm going to use equation 1, 3x minus 4y minus 20 equals 0. And I'm going to do that substitution. So let's put equation 1 here. The equation is 3x minus 4y minus 20 equals 0. And then instead of saying the letter x, I'm just going to do my math synonym, plug that in. So it's going to be 3 times negative 3y minus 2. And so as you can see, that's only my replacement for x. The rest of the equation stays the same. So negative 4y stays the same, negative 20 stays the same, equals 0 is there. Great. And now all you need to do is make sure you're expanding this. So this is going to be 3 times negative 3y is going to be negative 9y. 3 times negative 2 is going to be negative 6. And then again, all the rest of the equation stays the same for right now. Very good. And then, last but not least, we bring together our like terms. So I'm going to rearrange this to bring together my like terms. I know that negative 9y and negative 4y are like terms, not because they're negatives, but because of the y's. They're both attached to y. And then here I have two numbers by themselves. I've got negative 6 and negative 20 equals 0. So why am I allowed to do that? In math, it's very important to remember something really, really simple that no one ever taught me until way later in math. So the reason I was able to rearrange all this stuff is because of this concept. The concept that 3 plus 2 plus 1 equals 6, right? But so does 1 plus 2 plus 3. And so does 2 plus 3 plus 1. So as what I'm trying to say is that as long as the numbers are the same and their signs are the same, because as you can see, these are all positives, they were stayed on the same side of the equation, nothing changed. They're going to equal the same thing. So that's why I'm allowed to move around these like terms to shift them. And when I used to, when we teach this to kids in school and for our tutoring programs, we actually give them like little slidey things so that you can slide things around and do that. It's a very cool way to understand it. Anyways, point of the story. So negative 9y minus 4y is going to be negative 13y. And for anyone who's joining for the grade 10 class, welcome. We're going to get started shortly. We're just going to wrap up this grade 9 question, which is actually also a grade 10 question. So if you want to stick around and take a look, that's actually what we're doing. So then negative 6 minus negative 20 is going to be negative 26. All of that equals 0. We need to isolate for y because the whole point of this is to give ourselves an answer for y and for x, right? So I'm going to isolate that. So it's going to be negative 13y equals positive 26 because I'm moving it over to the other side. And then I'm just dividing off negative 13, which works out really well because that makes y equal to negative 2. Okay, so I've now solved for the y value. I'm going to take this y value and plug it into whichever equation I think looks easier. And for me, that's going to be equation 1 right now. So equation 1, as we know, is 3x minus 4y minus 20 equals 0. So wait, let me just do this. This is step 2. Use your math synonym, aka substitution. Awesome. And I'm just going to take this value of y and plug it in instead of the letter y. So all that I have to do is very simply plug that in. And then I just do the multiplication. So I get 3x. Negative 4 times negative 2 is positive 8. And then negative 20 stays the same for right now. So now we need to isolate for x. So first thing I want to do is simplify this. So 8 minus 20 is going to be negative 12. So my next step is going to look like this. And then I just want to get everything away from x. So it's going to be 3x equals 12. Divide by 3 on both sides. And then x equals 4. So my final answer, because remember, this time we solved for y first, so it's important to remember that. So my final answer, first of all, this is step 3. Plug your answer into either equation. Wonderful. And, oops. Then your final answer, remember that x has to be first. That's really important because we always write our points on a Cartesian plane as xy. Always, always, always. So our final answer is 4 and negative 2. Yay! Okay, so I hope that this was helpful for you guys in the grade 9 class. Again, sorry to the grade 10 class, we started a little bit late, but this is also grade 10 concept, so it's okay for us to work on this in the grade 10 class, actually. For those of you who are looking for more in-depth answers like this, if you go into our YouTube channel, I think the first week of videos that's on the YouTube channel, like the first live stream that's actually on there, I do believe I touched on this. I could be wrong though, so just check it out. It would be in the grade 10 class, which is the second half of the grade 9-10 live stream from that day. But Irfan, I hope this answered your question. For anyone who's watching that wants to build up their math skills over the summer, and I know you're going to say to me, oh my God, you're crazy, lady. How dare you say that I should do math over the summer? I know you're probably thinking I'm nuts for even suggesting this, but if I can give you any advice, thank you, Irfan, for your questions, is message us on scholarlyelite.com. We actually have a new website. It looks really cool. So message us on scholarlyelite.com if you want to take a free math assessment, and we can pre-teach you the next year's math class so that you have no struggles whatsoever next year. Because with all the math that you guys missed this year due to all the strikes and all of the, obviously because of COVID things being closed, it's going to be really hard next year to work on math in the capacity that you would have been doing it before. So if you want to work on your math over the summer and you want to pre-learn next year's curriculum so that you're just going in ready, I don't know, does that sound like a ridiculous idea to you guys? Being prepped, it'll make you feel, I think it'll help you a lot. So anyways, if you're interested, message us there. But without further ado, we're going to get started with the grade 10 class. And we will get this show on the road. So if you are from the grade 9 class, you want to stick around, you're more than welcome to. We're definitely going to be teaching some things that are important for grade 10. Today we're working on analytic geometry in grade 10, which in my opinion, and the reason I've left it this far into the classes is because it's not really the most important skill, but it is something that you do need to understand. So we're going to be talking about midpoints of a line segment and finding the length of a line segment and developing the equation of a circle. So if you guys haven't done this unit yet, definitely let me know if you have questions. Even if you have done this unit, if there are things I'm mentioning that you are wondering about, you're more than welcome to listen in, because obviously this is, again, an important part of math. Sorry, I needed to drink water because I've been talking all day today, and I'm going to be talking for the next couple of hours. So, alrighty, guys. Let's talk about the midpoint of a line segment. First and foremost, let me open this up because sometimes when I do this, it doesn't let me do it on the same screen. Great. So there's my Cartesian plane. And we're going to say that if we are solving for the midpoint of a line segment, literally just the middle of a line, right? But in math, and especially for those of you who might be interested in going into the sciences, into engineering especially, this is a really important concept, because sometimes finding the midpoint of a line is actually the way you're going to be able to solve something. And for those of you who might eventually take linear algebra, this is a really important skill to understand. So the midpoint of a line segment is literally the point on the line that is the same distance from either the end point or the other end point. And if we look at it like this, let's say I have a straight line like this. And oh my gosh, that's not even a straight. I guess it is. There we go. Great. So say I have this and I'm calling this point A and this point B. And let's pretend I found out exactly the middle. This is not going to be exactly the middle, but let's just pretend, you guys. So that's the midpoint. And there is a mathematical formula for solving this. So that formula goes like this, because usually they're going to ask you to solve this on a Cartesian plane. So let's say that A is at point X1, Y1, and B is at point X2, Y2, and I'll explain what that means in a second. The formula is going to be midpoint of AB, line AB is what they're really saying, is X1 plus X2 divided by 2, comma, Y1, that's a 1, plus Y2 divided by 2. And this is going to give us an actual answer in the format of X, Y. So usually when we get questions like this, and I'm just going to put some colors up here because that's how it goes. Da, 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 da. So let's say I have my points here. I've got this point and this point, and finally, this point. Okay, so let's draw the straight line here. So we've got here to here. I've got here to here. And as we can see, this is obviously a triangle. Okay, So first things first, if you're given a question like this, if they haven't labeled stuff for you, you want to label stuff. Oh, I need my pen, not my straight line. So we've got A, I'm going to label that, and I know that that point occurs at -5 and y equals 2. Then I've got point B, which is occurring at x equals 3 and y is -3. And I've got C, which occurs at 3 and 2. Yay! Okay, so let us get to the point here. What they're going to ask in a question like this usually is something along the lines of determine the midpoint of each side of the triangle shown below. So when we're given a question like that, first we need to determine what are the sides. Okay, that's my first thing I always want to do. Because obviously this triangle is made up of 3 line segments, and I want to first give myself a breakdown of what those line segments are. So I'm going to erase the formula here for a second. We're going to come back to, we're going to write it again in a minute. But I just want to make some space so that everyone can see what I'm talking about. And again, like I said, this isn't the most complicated part of math in grade 10 for sure, but I do want us to go over this because I did have a goal of getting through pretty much the entire curriculum as much as possible, especially all the main stuff that's actually important. So there's that. Okay, now let's take a look here. If I've got 3 line segments, I'm going to call this first line segment AC. That's from here to here. And then I've got line segment AB. And I've got line segment BC. Or CB. It doesn't really matter how you say it. They mean the same thing. But I'm going to say BC. Okay, you guys. So they want the midpoint of each line segment. And if we recall our midpoint formula, it is as follows. I'm going to write it down here because it's just that way we can refer to it. So the standard midpoint formula is so midpoint of whatever the line is. So let's say, whatever. I'm just going to do that. Basically, it's going to look like this. x1 plus x2 over 2, y. So y1 plus y2 over 2. Okay, so you guys, first things first, what I want to do here is actually determine what my points are and which is which. So if this is line segment AC, I know that point A is -5, 2. I know that point C occurs at 3, 2. And what I want to do is actually label these right away. So I'm going to call A my point 1. So that's going to be x1, y1. And I'm going to call C point 2. So it's going to be x2, y2. Okay. Now, knowing this information, I can take my equation again. So if I'm going to write, and I always rewrite my equations, it's a great way to get that extra full bonus point. So if I want the midpoint of line AC, what I'm going to do is I have x1 plus x2 over 2, comma, y1 plus y2 over 2. And this is going to be like this. So if I know my x1 is -5, I'm going to plug that in. Actually, let's move this over a bit just to make it a little bit more space for you guys. So if I have x1 equals -5, that's going to be -5. And then x2 is 3, that's going to be +3. Remember that that plus is not movable. Whatever the number is, you have to plug it in the value that it occurs in. So if the value of x is negative for x2, I would have had to plug it in as negative, and it would have been plus negative whatever the number is. So that's important to remember. And then for the y's, we've got y1 plus y2, so that's 2 plus 2 divided by 2. Let me actually just erase this little bit of extra that I've got here. Cool. Awesome. So negative 5 plus 3 is negative 2. So here we've got negative 2 divided by 2. Then we've got 2 plus 2 divided by 2, which is 4 over 2. And our final answer is going to be, so negative 2 divided by 2 is negative 1. And 4 divided by 2 is 2. So if we take a look here, and I've got negative 1 as my x and 2 as my y, this is the midpoint of AC. And it makes sense because if I was to count the number of jumps from that point, so here I go 1, 2, 3, 4, here I go 1, 2, 3, 4, that's exactly in the middle. Okay? So there's that. Let's do line segment BC. So again, my number one tip for all types of questions like this, it's really, really, really the best thing you can do is to write everything down. Write the formula down, write the letters down, all of it. It helps, guys, I promise. So again, for my A, I know that I've got the point as negative 5, 2. And I'm going to call that x1, y1. And for B, I've got the point 3, negative 3. And that's going to be x2, y2. Again, I'm going to write the formula. This time I'm specifying that it's midpoint of AB. And again, that's going to equal x1 plus x2 over 2, y1 plus y2 over 2. Cool. And now we're going to plug everything in. So we know that x1 is negative 5. So we've got that there. x2 is positive 3. So let's add that. Divided by 2. Cool, that's the x's. Now the y's, we've got positive 2 as y1. And this is where that kicker is, what I was talking about earlier, right? So the equation is y1 plus y2 divided by 2. Therefore, I've now plugged in y1, which is positive 2. I have to keep the positive from the equation as it is. So it's going to be plus negative 3, which is our y2. Okay, so let's break this down. First, let's do the x's to get our answer here. So negative 5 plus 3 is going to be negative 2 divided by 2. And then on this side, we've got 2 plus negative 3. This is where our knowledge of integers comes in. So 2 plus negative 3 is the same thing as saying 2 minus 3, which is going to be negative 1 half. I mean, negative 1 over 2 is what I'm trying to say. So the final answer here should actually be equals negative 1, because negative 2 divided by 2 is negative 1, and then negative a half. I highly recommend leaving everything as fractions. That's really the best way to do it. So let's plot this, okay, you guys? And this is where it gets interesting, because as you can see, this is not a horizontal line, right? It's obviously on a slant. So that's why this equation is so important, because it can help you solve for that midpoint even when stuff is on a slant. Okay, so let's take a look there. If I've got my x value as negative 1, I'm going to look at that there. My y value is a half. That makes total sense because that's right on my line. And I know that that's the midpoint of AB, which I can also write as negative 1, negative a half. And I should actually put the value of midpoint of AC in as well, which was negative 1, 2. Okay, last but not least, and again, like I said, we're not going to focus on this topic forever. It's not that crazy difficult of a topic. It's just that I need us to get through it so that we can understand lots of other stuff as well. So last but not least, we've got line segment BC. I want to put my numbers in first. So B is 3, -3, and that's going to be my x1, y1. And then I've got, actually, let's get rid of those brackets there because that's just confusing people. And then I've got C, which is 3, 2, and that's going to be x2, y2. Again, for full marks, we want to write our initial equation, our standard equation. So without any numbers in it, that's x1 plus x2 divided by 2, y1 plus y2 divided by 2. And that is going to equal, so x1 is 3, x2 is also 3, which is nice. And that's going to be divided by 2. And then we've got -3 as y1. And that's plus +2 divided by 2. And we've got, so 3 plus 3 divided by 2 is obviously 6 divided by 2, which is 3. And then we've got -3 plus 2, which is -1/2. Sorry, -3 plus 2 is 1, -1, I mean, and then divided by 2 is -1/2 is what my brain jumped to. So that's our midpoint for line segment BC. So let's go ahead and make sure that that's correct. It makes sense, obviously, that we have our line segment X on the 3 because that's where this is. It's a vertical line. And then right here at -1/2, that's the midpoint of BC, and we know that that value is as such. Yay! Okay, so there we go, you guys. I hope that that made sense. I mean, I hope it was helpful. I'm going to sip of water here while everyone just writes that down if you're writing stuff down, and we're going to move on to the next piece. Which is the length of a line segment. So it gets interesting. Okay, so I'll leave that up for like 5 seconds and then we can get rolling. Okay, you guys, we're going to try out something a little bit different. So let's get rid of this page, start up a fresh one, grab our Cartesian plane here. Cool. Make this a little bit larger so everyone can see, because I have learned now that we've been doing this for like 12 weeks or something that sometimes it's hard to see. So we are going to be doing something where we're learning how to solve the length of a line segment. It's very similar to what we call the distance formula. Both are very important. They're basically the same thing. It's just about understanding how they are similar. Because sometimes when we're solving for distance, we're using real life problems, and a line segment is more of a conceptual problem. Oh, not what I was trying to do. There we go. So let's put some color on this bad boy. Let's use purple because I happen to love that. So let's say I have line segment here and we've got, point B here, and let's say point A is like right here. Do that. Ooh. So this is my line segment. I'm gonna try and, I wish that this silly thing had like a straight line only with not an arrow. Very annoying. And I don't think there is one. I mean, why is there an electrical plug and not this. This is why we don't use this this service for our tutoring. We actually use like a top of the line thing, but for proprietary reasons, we're using this for now on here. If you tutor with us over the summer, or if you're in our Elite Math Mastery program, which is obviously, it's both a tutoring and worksheet program so that you can actually pre-learn the next year's curriculum. So like if you wanted to pre-learn grade 11, we would teach you everything in advance so that even if you missed school next year, you would know everything and you would never have to worry about missing class. Doesn't mean you shouldn't go to class. It just means that, you know, if you're sick or something, you won't fall behind. So what I'm saying is that the system that we use has a really good program for this. But anyways, okay, so here's my line segment. Cool. Now, go back to using the pen. So with this line segment, I'm going to call this point A and this point B. And one thing to remember is that obviously A occurs at some, sorry, let me write this like this. We've got point A, which occurs at x1, y1, and some point B that occurs at x2, y2. That is arbitrary. It doesn't really matter which one you pick. I like to tell people that pick the x1 as being the value that's like lower in value on the x-axis. So for example, 2 is lower than 5, obviously. So that's why I've picked that as x1, y1. But in general, it's relatively arbitrary. It doesn't really matter which one you pick. Okay, cool. So let's draw in our, sorry, our dotted lines here. So when I've got something like this, let's say I have this like imaginary point C, right? So here, from here to here is also the same thing as saying x2 minus x1. Obviously, because if you think about it, the distance from here to here, from 2 to 5 on the x-axis, is 5 minus 2, because 5 minus 2 is 3, and this is 3 boxes away. Let's use that same concept up here. So if I'm looking from the distance from here to here, then I can explain that by y2 minus y1, because again, I know that this is 3 boxes away, and I'm going to get 5 minus 2, and that makes sense. So the equation for this is that the distance squared equals the length of A to C squared plus the length of B to C squared. And if this equation might not look familiar to you, let me put this into terms that we've seen before. So if we think of this as a triangle, right, then this is a 90-degree triangle, right? And that means that the line segment AB from here to here is our hypotenuse. I always spell hypotenuse wrong. I feel like that was wrong. Hypotenuse. There we go. I think that that's right. It doesn't really matter. Point of the story is it's the hypotenuse, okay? A to B is the hypotenuse. So what we're really saying is AB squared equals AC squared plus BC squared, which if we remember our Pythagorean theorem, we know that A squared equals B squared plus C squared. A squared being the hypotenuse, right? So that's really where this formula is coming from. We're solving for the distance in the same way that we solve for the Pythagorean theorem. So don't let this confuse you, because it really is a lot more simple than you get explained it for the most part. And I say that in the sense that like most textbooks don't really explain this. They just kind of like put all these letters there and expect you to extrapolate that information. And I personally believe in something called direct instruction, which is where you give students all the tools to solve things so that they're not constantly having to go back and like figure stuff out Nick Cage style, like trying to find the Constitution and blah, blah, blah. Anyways, you guys are probably too young to know what I'm even talking about. Point of the story is that I want this to be as direct as possible. If you guys have questions about what I'm saying, please feel free to leave them in the chat. That's what we're here for. If you have questions that don't have anything to do with this lesson, that's fine as well. Honestly, that's really what we're here for, is to solve as many of your questions as possible, even if they're not about the lesson we're teaching. Because what's the point of this being live if you can't ask questions, right? And that's why we knew that a lot of teachers' unions are not letting teachers actually do this, where they're doing live instruction. So that's why we've taken this on, to try and help as many kids as possible. Okay, point of the story. I'm gonna stop talking about that. So in the context of this question, like I was saying, we labeled A as x1, y1. We labeled B as x2, y2. So the way that we can solve for the distance is actually by doing this. So x2, which is the x value of point B, minus x1 squared plus y2 minus y1 squared. And then obviously, because this distance or d value is squared, I need to square root both sides in order to solve for the actual distance, because obviously that's how you get the core answer to what you're saying. So I'm gonna try to write a straight, there we go. So x2 minus x1 squared plus y2 minus y1 squared. Okay, that's our final equation. Okay, so let's talk about using this formula. And we're going to apply it to this question. So first thing I want to do is solve what my points are. So I'm going to say point A occurs at x equals 2, y is 2. Point B occurs at x equals 5, y equals 5. So I'm going to also label these x1, y1, x2, y2. And then I'm going to use my formula. So let's just plug everything in and get the distance of this question. This line segment is what I'm trying to say, the length of it. So remember that in the context of this type of question, distance and length mean the same thing. So plugging in my original equation, as you guys have heard me say like a broken record, literally always plug this in. On any test, assignment, whatever, teachers actually are more inclined to give you full marks if they see you structuring questions really well. Why is that the case? Well, there's a couple reasons. First of all, it indicates that you understand the methodology and what you're actually doing. You're not just arbitrarily plugging stuff in. And B, it also helps keep things organized. And I can tell you, as someone who's seen hundreds of tests, probably, I don't even know, hundreds is probably a small number. Like I've probably seen thousands of tests in my years of education. And it's really, really interesting that sometimes and actually not just sometimes, a lot of the time teachers give out better marks to people who have neater tests. And part of having a neat test, even if you don't have super neat handwriting, it's actually easier to mark a neat test, and you're more likely to get good marks or neat marks. Anyways, point of the story. Let's get these numbers in here. So we know that x2 is 2. Sorry, is 5. My bad. x1 is 2. Put those in brackets. Square that bad boy. Plug in our y2. y2 is 5. Same dealio in this case. So we, again, need to show all of our steps. This is a great way to get full marks in high school, is just to show as many of these dumb steps as possible. Because again, that's how the Ontario curriculum is created in order to, get this done. This is a very good way to do that. So we've got 3 squared is 9, plus 9, all under the square root sign. So that's really 18 plus 9. And the square root of 18, oops, is 4.24. Okay. So now let us go ahead and take this information and use it in a word problem. Okay? Because that's really where these come in play for the more complex versions of these problems. So I'm going to put up a thingy here. Actually, do I have a Cartesian plane that's not? I guess this. Because we're going to use our own Cartesian plane here in a second. Oops, there we go. Okay, so let me type in the words here, because this is quite a doozy of a question. Just give me a second. So a fishing boat sends a distress signal from a location given by the coordinates 200, 180. An ocean firefighter, I didn't know that those existed, but that's pretty cool. I read firefighter. The word is freighter. Guys, what's wrong with me today? An ocean freighter at coordinates 170 and 240, and a cruise ship. Let me just put this in the next line. And a cruise ship. I always thought cruise ship was one word. I guess it's not. At coordinates. Wow, even my typing sucks today. The coordinates 230 and 180 pick up the distress signal. Which ship is closer to the fishing boat? So like I said, this is not a complicated concept, but they will use really annoying questions like this to kind of make up for the fact that it's not a complicated concept. Okay, so there's this. I'm going to erase some tings here as well because it annoys me way too much. Okay, perfect. Get rid of that bad boy. Clean looking as we can. Okay, good enough. So we got that. Now, first of all, whenever I'm doing a question like this, I personally think that the best thing you can do is draw it out. Now, because I don't have any negative values, I'm not going to use a full Cartesian plane. I'm literally just going to use the first quadrant and, use it as a graph. I wanted it to be black. There we go. So let's do that. So we got this and we got that. So again, you want to draw stuff out. It's just going to make your life so much easier, you guys. Now I'm going to pick my values. This is obviously X. This is Y. I need to pick the scale. So these are just going to be coordinates basically. Now, if I know, let's count this. 1, 2, 3, 4, 5. I want these on the lines. Because you're going to have to do this in class and like showing your work and showing the drawing is actually going to help a lot. So 1, 2. Okay. So I'm going to make this in increments of 20. Does that make sense to me in terms of how, oh my gosh, super annoying. There we go, ish, good enough. So 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 300, And same over here, 20, 40, 60, 80, 100, 20, 40, 80, 200. Okay, so we might have to extend this a little bit, but 60, 260, I mean. Okay, cool. So let's plug these in. We've got the fishing boat. I'm going to call this point A, and that's going to be at the value 200, 180. So let's graph that. This is the guy that is in distress. So here we go. He's here. That's point A. Actually, I'm not going to put my point in yet, like my letter. 200, 20, 40, 60. Cool. That is our fishing boat. Now the ocean freighter is at 170, 240. So that's 20, 40, 60, 80. So right here and 240, which is here. Cool. And then my cruise ship is at 230 and 180. So that is right here. Now, when we draw this, it kind of gives us an idea of like where people are and blah, blah, blah. I'm just going to label this. So this is A for our fishing boat. This is B. This is B, I'm trying to say. Point B. And this is point C. Okay. So point B is over here. Point C is over here. Now, kind of looking at this, we can already tell like which is going to be closer, but that's not the point. It really comes down to the fact that we want to know the distance of each from the fishing boat, and so we're going to have to solve for that. So what we're going to do now is break this up, and the best thing you can do with these kind of questions is just literally label as much as you can, keep things as close as you can in terms of like, you know, everything that goes under one heading should stay together. So distance of line AB. Okay, so that's this line. That's the distance from the fishing boat to the ocean freighter. And what we really want to do is, first of all, write our distance equation. But even before that, we want to write out what our coordinates are. So if A is 200, 180, and B is 170, 240, I actually would recommend typically making B as x1. It doesn't really matter though. Like I said, they can just be chosen as long as they make sense with one another. That's all set. Okay. So let's put in our distance formula. Distance equals the square root of, oh my God, that straight line gets me every dang time. Square root of x2 minus x1 squared plus y2 minus y1 squared. Yay. Okay. So now let's go ahead and plug this in. So x2 is 170. Actually, let's put that there first. So 170 minus 200 squared. So the reason why it doesn't matter which one you pick is realistically A, because you're squaring it. So even if it's negative, it doesn't really matter. 200 minus 170 is going to be 30. Squared, it's going to be 900. 170 minus 200 is going to be negative 30. Squared, it's also going to be 900. So that's why it doesn't really matter. There's also other reasons, but they're more boring and we're not going to get into them. So we've got y2, which is 240 minus 180 squared. Okay, so again, you're going to want to just show every step. So you've got negative 30 squared plus 40. Oh, sorry, negative 60 is what I meant to say. Or 60 in this case. And that gives us square root of 900 plus 3,600 or 3,600, however you want to say that. And approximately the square root of that addition is the square root of 4,500, and that equals to 67.082, give or take. So that is the distance between the fishing boat and the ocean freighter. Okay, so now that we've got that information, we're going to want to solve for the other one. So the other one, we're trying to find the distance of AC, which is here. And our coordinates are A is, again, 200, 180. And C is, where did it go? Oh gosh, my eye is so itchy, you guys. Sorry, give me 1 second. Sorry, my eye was driving me literally crazy. So let's go ahead and plug these in. So then C is going to be 230 and 180. Now, again, we need to determine which one's x1, y1. In this case, it makes sense to do this. Like I said, again, for this type of question, it doesn't really matter. And then we're just going to plug in our distance formula. So we've got x2. And for anyone who's just joining, the reason we plug it in every time is for those extra marks. And like, honestly, I say it's for the extra marks, which is very true, because you do get, it's not that you get extra marks. If you're looking for that full 4 out of 4 type of mark, your teacher needs to know what algorithm you are following. And so that's what's happening here. You're showing them that information. So let's plug this in. That's a terrible sign, but you get what I'm saying. So 230 minus 200 squared plus 180. Dang, is this really 180 minus 180? It is. Cool. Well, that's cool. That's fine. So 230 minus 200 is going to be 30 squared. And 180 minus 180 is 0. 0 squared is 0, so we can just leave that like that. And then here we go. We've got the square root of 900, which is obviously going to be 30, because we're basically saying, what is 30 squared? What is the square root of 30 squared? Well, it's just going to be 30. That makes sense. So 30. So if these were, obviously these were just coordinates, we can assume that we can just call them units. So this is 30 units away, and this one is 67 units away. So that tells us that the cruise ship, this one, is the closer ship to the fishing boat. If this was a word problem on a test, you would write a sentence indicating that, because that's very important. And we have 11 minutes left, so I'm going to try to squeeze in the lesson about developing the equation of a circle. So let's do that. If anybody needs me to come back to this screen, I will. Just let me know in the comments, okay? But there you go. Again, like I said, today's not the most complex lesson. It's really about understanding these concepts on a, what I like to call a granular level, a really deep and specific level, so that when you do get the complex versions of these questions in word problems, you're not stumped whatsoever because you have such a strong understanding. Like I've said before, it's very important that you understand that. For those of you who are new to Scholarly Elite, or you are thinking of joining us for one of our summer elite math mastery programs, basically what we really, really stress is understanding foundational math skills. And is it ridiculous to think that like just doing 1 hour of extra math over the summer will make your life so much easier? Like, is that a ridiculous thought? It's up to you, right? It's about whether and what it is that you want for yourself for next year. Do you want to go into next year knowing everything? It's really down to that. So anyways, okay, we've got our coordinates here. So let's say I have a circle. Let me get my circle shape here. So let's say I have a circle and it goes like this. I want it to be center. Now let me try to get it as centered as possible. Three. I don't know why it's like, I guess it's an oval without me even realizing it. Like our brains trick us into thinking something's perfectly circular, when in fact it has more of an oval shape. Okay, there we go. I got it. Yes. So here's our circle. Let's say that we have our point of origin at 0, 0, right? And that would literally be called O, 0, 0. And that obviously every circle has a radius. So let's use our tingamabob here. There we go. So if a circle has a radius as we know is half of the diameter, which is the distance from one end to the other of a circle. There we go. Good Lord. Really taking his time. Cool. There we go. And then here I have that radius line pointing to some point right here that we can denote with X and Y. Cool. So first of all, I want to show you guys something interesting. So any point on the circle can be represented by the ordered pair that I've drawn here, point X, Y. So the distance P to the center, which is 0, 0, as you can see, obviously, it's right at the middle, is the radius. And we use the distance formula that we just learned to get us the following result. So if I know that our distance formula is this, it is x2 minus x1 squared plus y2 minus y1 squared. Cool. Well then, if I was to use this distance formula for the length of this line segment, which is r, the radius, right? That would give us some point x, my square root again. So some point x that I don't know yet, minus 0, because that's that there. It's going to be my x1. We're going to square that, plus some point y minus 0 squared. And then, because of these subtractions with 0, we actually get this equation to be x squared plus y squared equals the length of the radius. So that's pretty cool. And what I like about explaining this is that, like, literally I've almost never seen I've never seen teachers actually explain this. And, you know, that's every teacher's prerogative. And I maybe just haven't come across a teacher that explains it. And I'm sure the teachers know this. It's just something that I found very, very interesting in terms of determining this. And I'm a kind of person who likes to know the reason behind why things are in math the way that they are. So anyways, that's kind of that. But so we've got this equation. And as we know, we can also have the equation squared if we want it to look like this. R squared equals x squared plus y squared, because it's just easier that way, right? We squared everything, we got rid of the square root symbol, it's very much better. So the equation of a circle, let me write this out for you guys. The equation of a circle with center, oh my gosh, did I just do that? With center 0, 0 and a radius that we denote using the letter R, is going to be x squared plus y squared equals r squared. Cool. So the kind of questions that you're going to get for this part of this unit are going to basically say things like, figure out the equation of a line with the center 0, 0 that passes through some point. So let's go ahead and solve that so that we can actually get ourselves the equation of this line. Okay, so let's go ahead and do that. Now let me do something here. Oh, not what I was trying to do. What I'm trying to do is oh my gosh, there we go. Well, let's just erase this part because that's where it's going to get annoying. Might as well not waste time. So let's say, for argument's sake, not argument's sake, let's say that this is our question. So, what is the equation of a circle with a radius of 8 units and a center located at the origin? When they say the origin, what they mean is 0, 0. So keep that in mind. So I'm going to write that down. Origin is 0, 0. Okay. And sometimes I'm just a fan of rewriting all the words that we have in the question, all the main stuff. So 8 units. And what is our equation for a formula? The equation of a circle is x squared plus y squared equals r squared. So keeping this in mind, what we need to do now is literally plug in what we know. Well, I know that r is 8. So this is going to look like this. X squared plus y squared equals 8 squared. And then we need to go ahead and actually do that math. And that's what we get. Yay. Okay. So let's see if I have time for one more quick question. Let's do a question where we're determining the radius of a circle because that's also really important. Okay, so you guys got this down. If anyone needs me to rewrite this after, just let me know. Also, these always get posted on YouTube after, God be willing, I'll be posting this one after as well. That way anyone who had to leave early or missed something can keep track. So determining the radius of a circle, hopefully we have time for this. We did start a little bit late, so if we end up going like a couple minutes over, it's not the end of the world for me. So determining the radius of a circle. So remember that the equation of a circle with the center at 0, 0 and radius r is x squared. The equation is x squared plus y squared equals r squared. And when we know this, we can determine the radius by using the points. So let's say they've told us to determine the radius of the circle defined by the equation x squared plus, I wish there was a way to just do squared. I know that there is, but not a simple thing, so we're just going to do this. So this is the equation of the circle. My pen back in play here. So we've got x squared plus y squared equals 81. So that's what this looks like. X squared plus y squared equals 81. And remember that the original equation of a circle tells us that when it's x squared plus y squared equals to whatever, it's r squared, which tells us that r squared is equal to 81. And then if we just square root both sides to get rid of that squared from r, we're going to get our answer. So r the radius is equal to, oh, that's supposed to be a 9, equal to 9. Yay! Woot woot! Anyways, you guys, so we can continue this part of this lesson next week because there's quite a bit more stuff. There's quite a bit more for us to go over, and I don't want you guys to only get half answers, basically. But if you do have questions in the meantime, feel free to submit them. You can either, submit a form through our website, which is scholarlyelite.com. Check it out. We just launched a new website. It looks pretty cool. We actually haven't officially announced it yet, so you're the first ones to know. No big deal. Or you can just email us directly at admin@scholarlyelite.com. But if you are interested in pre-learning grade 11 math for next year so that literally you never need to worry about math again, you can go to scholarlyelite.com, go to the math page, and submit the form for the Elite Math Mastery. We have a lot of kids starting actually in the next few weeks so that they can pre-learn grade 11 math, because grade 11 math is a nightmare. So I don't want anyone to get worried about that. So anyways, I wish you guys an awesome week. Stay safe out there. I hope that you're healthy and well, and I will talk to you again next week, same time. We've only got a couple weeks left of freemathhelp.ca. We're going to be wrapping everything up by the end of this semester. So if you have questions that you want answered, now is the time to submit them so that we can answer them over the next 2 weeks, okay? So wishing you guys an awesome week. Talk to you again next time, and we'll see you soon. Have a good one. Bye.